So I've made my different atoms here. I need 4 atoms of iron. So for this I've used my red plasticine. So as you can see, they're all roughly the same size. And each iron atom has 3 bonds. Now the way I've put them together is I've just put 2 together to show a double bond, which will be a bit clearer in a minute. So I've made my 4 iron atoms. I have 3 molecules of oxygen. Now each molecule has 2 atoms. 3 times 2, I have 6 atoms of oxygen. So I've made them in a different colour. Don't worry too much about size, but I've tried to make them roughly the same size. Now you could show them, because each of these has 2 bonds, which would be the equivalent of 2 of these each. So they would be bonded together like that. So I've split them all up. Now I want to put them together. Each molecule has, if we ignore the 2 at the front, has 2 atoms of iron, 3 atoms of oxygen. So I'm also going to put those 2 out of shot for the moment. And I have 3 oxygen, so I'm going to get rid of 3 for the moment. Now each oxygen can have 2 bonds. So for the first one, I'm going to shove it in the middle. And now you can see I've got 2 bonds here. So I'm going to pop them both in. Ooh. The bonds on a real molecule wouldn't be quite so far away, but the cotton buds show it for the sake of argument. So that is now one slightly unstable molecule. 2 atoms of iron and 3 atoms of oxygen. And if I move that slightly precariously over there and bring my remaining ones back in, I'm going to do the same again. I'm going to set them up in exactly the same arrangement. I'm going to put 1 oxygen in the middle, so it's got 2 bonds. I'm going to put another one over here, and that's got 2 bonds, because each oxygen atom has got 2 bonds available. So if I double check once I've shoved them all in, once again, each iron atom has 3 bonds, each oxygen atom has 2. And if you see now what I started with, I've ended up with 2 molecules of iron oxide.